Okay, so for people who are watching this live stream, this is another episode of our internal design work on supporting chemistry as a built-in feature of Wolfram Language. And we are about to see some things that have been done. So where do I start? Jason, what should I do here? That packet install has been done. So
okay. So to autoload the package, you evaluate just the word molecule there.
Okay, let's look at your screen.
Okay, so yeah, so it should work when you run packlet install on this. It's something I'll have to work out.
Why don't you just maximize that window?
Right.
Okay.
Okay, so so the basic object is a molecule. It has arguments. You could give it the atoms, the bonds, the stereo elements.
And why do we think that those are? Why do we? I mean, we've discussed this before. Well, let's see an example of a molecule here.
Right. So this would be TNT. If you were to enter it by hand, you would enter molecule, a list of atoms. Some atoms have a formal charge, and you need to specify that, or else it doesn't work out. And so you can specify that via property.
I'm not really keen on that use of property. I mean, I think did we have an alternative to that from before?
I didn't. I mean, this is what I found that to work. Otherwise, we talked about using associations here, but let's see. But just using a list where you have naked strings and then associations didn't seem right. So
I think that's okay. I mean, that's really okay, because the naked string. Well, what are the possibilities here? Is it mostly the case that there will be a formal charge? Is that the primary modifier that you'll see? Or are there lots of modifiers that you might see?
There are lots. So you could imagine a mass number, the radical number of radical electrons. It turns out it would be important to label certain atoms so that you can refer back to them.
Okay. Well, okay. So first of all, that sub list of around formal charges obviously shouldn't be there.
Okay.
Right? The sub list there, right?
So if there's just one property,
okay. You shouldn't have that there.
Okay.
Right? But I mean, okay, I'm not a big fan of this property wrapper. And I mean, these things are basically atoms, right? That's what one could imagine, given that you're using bonds down there, we can imagine some kind of wrapper that, I mean, I don't really like the word atom. I think we talked about that before, but that would seem to me to make more sense. And you could have the naked string, or you could have something which just says, roughly says atom. Is there another word for atom that we think we can use here?
Element, but that would be fraught with as much.
That's wrong.
Right.
That's not relevant either.
So I also wanted atom originally, but
but
it's too close to atom Q. So
I'm not sure. I mean,
I really think it should feel like it's designed for this domain. And yes, it's a different meaning of atom than atom Q, but it's safe. I think it's safe in this domain.
Okay.
Atom C, and then possibly a list of properties that it might have.
Right. So just type that in, for example.
And you only need that wrapper if you want to have additional properties, right? Presumably.
Yes. Right. Get rid of the braces. Right. So now, and it is possible that with this atom, I'm not really keen on this.
A molecule of atoms makes a lot of sense.
Yes.
So I like atom as well. Yes.
It's not an ion. Is it an ion? If it has a formal charge, it's an ion, isn't it?
No. So right. So a molecule, if the molecule itself had a total charge, then it would be an ion.
Fair enough. Okay. So listen. Also, the fact that those things are string, look like options, but they're strings, doesn't really, I mean, the full version of this should be something, I would think, where it's an association inside there, where this atom thing is an association. It says atom of association, element arrow n.
Or atomic symbol, or
yeah, atomic symbol makes sense. Atomic symbol makes sense. Atomic symbol is n, formal charge is 1, etc., etc., etc. And then this other form, these other forms, like just atom of n. And I could imagine that we would want to support something where it's atom of, if formal charge is the most common case. Is it the most common case?
Yes, I would say it's more common than mass number or radical electrons or the label.
What does radical electrons mean?
Unpaired electrons. So yeah, sometimes you have an unpaired electron and it makes it a very, you need to know that in order to do the bookkeeping so that you know that all your electrons are accounted for.
Okay, I'm so clueless about this. What is the difference between a formal charge and an unpaired electron?
Right, so a carbon atom wants to have 4 electrons around it. If it's bonded to 4 different things, it has 4 bonds, and there are 8 electrons in those bonds, but 4 of them are formally accounted to be on carbon. If you take away the hydrogen atom and both of the electrons in the bond, then you now have, the carbon now only has 3 electrons, and so it then has a formal charge of +1. If you take away the hydrogen atom and only 1 of the electrons in the bond, then you have an unpaired electron. There's no charge on the carbon, but it's highly reactive because it has that unpaired electron.
Okay, but so the names formal charge and radical electrons are meaning something very similar, but they are very different names.
Yes, I mean, so they mean something related, not identical. They have to do with the number of electrons around the atom.
Yeah, I understand, but okay. The next thing is, even for example, mass number. If somebody just saw this code, would somebody immediately know what that means? Or would, if he said isotopic mass number or something, then that would be kind of an immediate clue about what the thing actually is? Or even just isotope, right? Which you could just do if you put down there, isotope arrow whatever. No, in that atom there, isotope arrow whatever. It would be N, nitrogen 14 or something, whatever it is. That seems to me to make a lot of sense.
Okay, so
I mean, we could even call it, if we want to call it instead of atomics. Yeah, okay, go ahead. I mean,
so isotope was actually where we were at in the last meeting, and we moved to mass number.
Why?
You thought that isotope sounded not right, but I'm open to anything. Isotope is what I had originally.
Given that we're describing this as an atom. Okay, let's again, with this radical electron thing, I don't fully understand what that means, but let's come back to that. Let's keep going down to these bonds and so on. Okay. So
I think the isotopic one would be a phone name according to the standard IUC classification.
Okay, but this is like nitrogen 15. What is that 15 in nitrogen 15?
We say that, I mean, that is referred to as the mass number. It's the sum of the
proper technical term.
It's the sum of the protons and neutrons.
I know what it is, but I mean, when you say nitrogen 15, what one is looking for, that the typical sort of everyday version of that would be, uranium 235, carbon 14, whatever else, right?
Right.
Yeah.
And it just seems, well, whatever. Okay. Look, we don't have to solve this right this second. I think there are bigger fish to fry here.
If the word isotope occurs, it can be mixture, so it doesn't have to be integer anymore.
Why?
It's allowed to represent a statistical mixture.
In what sense?
80% carbon 13 and 20% carbon 14.
Would that be representing a mixture of molecules in a bottle, or the probability for a specific molecule?
I don't know the standard good enough to answer this question.
And
but I know that doesn't have to be integer from the unit tables.
Okay. All right. Well, maybe mass number is it. Okay. We don't need to go. Let's go back here. All right. Well, maybe mass number it is. But let go back to mass number. That's fine.
Okay.
For now. Okay, but I want to see. Okay, so these bonds, those numbers in the bonds are referring to the
indices of the atoms.
Right. So I have to say, I think label them. Did we talk about this before? Why not have in that first argument, if you want to label something, and I think we've done this in, for example, the neural net case, why not have the labels be of the form label, arrow, and then the atom? Do you understand what I'm saying?
Yes.
So in other words, most of those things would be just carbon or something, but you could say, you know, LAB, well, whatever. Yeah, right, something like that, which seems much more readable. Now, I don't know what the difference is. So those numbers, right, would just be, so this is, if you want to index into that, it's a little bit tricky, right? Because you've got to be able to index into that thing there. And it's like an association in the sense that the raw number gives you, yeah, I mean, yes, this is very much like an association. So the raw number will just index into the location. If those labels have to be strings, but I doubt that we're going to want those labels to always be strings. Am I making sense? So a possible approach to that would be to wrap key around it if it is not going to be a string.
Okay.
Okay. In the case of, I mean, I think you only need the key wrapped around it in the occurrence where it's defined in the molecule, I think. Not sure, I have to think that through a little bit. But okay. Anybody got any comments on this? Michael, Roger? No? Okay.
So the only uncertain thing I haven't fully figured out how to do is to then how to apply the labels after the fact. So say you make this molecule and then you want to apply the labels to certain atoms.
Well, apply them how?
So originally I was thinking that the label would be in the property wrapper, and then I would use set property.
Oh no. Please don't do that. How would you do that? You'd say set property of 13 or something to get the 13th atom?
Yes.
No, we've got to do it by the label that's on the atom.
Yeah, but
if there is no
label.
Well, they're all labeled or they're not labeled. I don't think there's any choice there.
What do you mean by all labeled? But you might not want them all labeled. But look, I don't understand why you're going to be doing that. Why not? As opposed to going back into the original molecule, you're imagining, for example, some graphical labeling mechanism. Is that right?
Right. Or so when I do a molecule plot of it, I have these as tooltips, and so that can tell me that this is atom number 2.
Okay, great. But then what would you expect to do to label them? Would you expect to go back to the input form of that molecule?
So I'm not sure here. I was thinking of using set property, but that's not.
It doesn't make a lot of sense because you're not going to know. I see. So your point is, if you look at that picture, and by the way, I'm not sure that showing molecule like that is the right thing to do. Do you really want to show molecule as just a thumbnail there, as opposed to showing it as a full, nice picture of the molecule?
So for version 1, I think at least this is good because let's see. I don't want to just make it the graphics. I would want it to be something really interactive, like graph. And
okay, but you also probably want the formula, and you might want the name of the molecule and things like this. So that's as useful as seeing a picture, I would think. Right? When you're actually working with these things, you want to see the formula or the name of the molecule. Right?
Yes.
But I think the correct thing to do would be to have that as some kind of label on the graphic, because I think seeing, it's pretty obvious it's a molecule. So seeing the word molecule there is kind of amusing, but not really important. What does the plus do?
Shows the smile string at the moment, but not.
Okay. Okay.
There are many more things here that could go here, like a molecular mass.
Yeah, it doesn't seem silly at all. Okay. Do other people have? I mean, that doesn't seem silly. The only thing that doesn't seem right to me is that annotation is useful, but seeing a bigger version of the graphic also seems useful.
I think what you can do, but depending on your development skills, might be a little bit tougher, is to do an attached cell. So if you have a full picture of a molecule, the attached cell can have an info box that gives the equivalent thing of that plus sign. You know, see what I'm saying?
Yeah,
you get
maybe.
kind of a summary of.
Well, is that? But we're not yet doing that for graphs, even, are we? We're doing it for images, but not yet for graphs.
We're doing it for meshes, and we will be doing it for graphs.
I discussed this with Jason. The thing that I don't like with it is that it only works if the thing is on its own.
The attached cell business.
Yeah. I find it.
Yeah, I mean, I don't understand. I think it's fine to do
this stuff.
Yeah, the IDAR.
I'm not a big fan of doing that for molecules. I think that's interesting, and we could do that. But I think it's useful to be able to see immediately. I would think certain properties of the molecule, like its formula.
Yeah. So then,
I mean, all I'm suggesting is that we make the default output be something that is plusher than that little tiny thumbnail, and then we have it is the thumbnail with some kind of info area underneath it that shows the formula, and that is simply our output form for a molecule, and it doesn't have the word molecule in it. Am I making sense? By the way, by having atom as a thing inside here, and bond for that matter, it's interesting to think about what the output forms of those should be. I suspect, yeah, I mean, with bond, we could in principle have an output form that just shows those numbers, and if it's an aromatic bond, it shows it with the appropriate, graphical form.
Right.
Makes sense?
Yeah.
Okay,
so
but let's move on, because we've got quite a bit more to cover here. So I think we're in pretty good shape here, except that I think that molecule output display should be plusher. Okay, let's keep going.
Yeah. So there's the bond, the stereo element.
Wait a minute. The order. So. The order is the aromatic, et cetera, thing.
Right.
Okay. Stereo element.
Right. So this it takes a second to understand exactly what these mean, but it's a way of describing the spatial arrangement of atoms.
Right. So it is the beyond. So what you've got is the bag of atoms, the graph of connections between atoms, and the third thing is something that is going beyond the graph, that is some more geometrical specification that is not at the level of the actual coordinates of the molecules, of the atoms. Now, where do we put in the coordinates of the atoms? How do the coordinates get added?
You can add them as an option to molecule. You can add coordinates goes to, and then a quantity array is what.
Wait a second. Is it coordinates? What would it be in a graph? It would be vertex coordinates, right?
Yes.
So you can't call it coordinates.
So what we're doing right now, but I wasn't perfectly happy with it, but in chemical data, we call them atom positions for the 3D coordinates and vertex coordinates for the 2D coordinates.
Yeah, that really seems kind of sucky. So, I mean, why not say, I see. So, I mean, it's a question of atom coordinates or something as an option name.
Mm-hmm.
But the thing you've just described, those are property names, which are strings.
Yes.
You see what I'm saying?
So, as of right now, I've got all the properties as strings, but there's no reason that something as fundamental as atomic coordinates would need to be a string.
That's not going to work. What properties do you have as strings?
So a property for a molecule, you can say hydrogens.
No, that's a query. That's a question you're asking, right? That's not something that is. What do you mean? Hydrogens is false. What does that mean?
So
that's a display option, right?
No, so internally you can keep the hydrogen in the chemical graph or keep them as implicit And
I
that's a
understand,
common
but
thing
the
to
actual
do.
molecule is still has the hydrogens. The question is that's a display option for whether you have them. I would think that's, when you do operations on the molecule, the hydrogens are there, presumably.
Well, oftentimes when you want to do
Why don't you
substructure
show me a
searching.
real molecule with its options included?
Okay, so I would say.
No, do you have one here? I mean, can you?
Right.
That one is
So,
an example.
so this one has got an input form. And so this one has explicit hydrogens. I have hydrogens as an option for the creation of the molecule.
It's not going to work to have string options. We already went through this, right? How many string options do you have?
Just a few.
How many? What are they?
Right. So yeah, and so these are all strings.
Okay,
so
but what does embed molecule do?
When you create the molecule, do you want to spend the time and the effort to generate the 3D coordinates at the time that you're creating the molecule and embed them and store them with the expression or not?
Okay, I don't think that's the right name at all. So, I mean, I think there's a question of whether, what you're going to have is something like molecular coordinates arrow, that there'll be some option name molecular coordinates. And by the way, how are you specifying whether you are giving them in 2D or 3D? Okay, so they can be a quantity array, but they could also be so the question is whether you want to generate them automatically, whether you want to generate them immediately, or whether you want to have them be lazy. Is that right?
Right.
Okay, so molecular coordinates arrow automatic would do something, but it's a question of what the different cases are between doing them. Okay, so I don't understand. If it's lazy, when would they be generated?
When you ask for them, when you do a molecule plot 3D.
Okay. Do we have a precedent for this? Roger, can you think of one?
Yeah, I think Charles, we have a bunch of things that are lazy. In fact, Charles, do you have some examples?
I'm not sure by lazy what you mean, but
well, that it doesn't compute it until you're trying to plot it. It doesn't. For example, the example would be a graph where it does not generate an embedding until you try to plot it. But that's the case in all graphs, right? You don't generate the embedding until you try to. Am I correct?
Yeah, that's correct. I mean, we don't. I mean, pretty much for anything we don't need, we don't compute unless when it's needed.
Right. So we just need a name for, which might be inherited or all or something like that for the case. Or we might have just a string that says, why don't you write this down? A string, vertical bar, and then the string there, something like pre-compute or something. Right?
Okay, yeah.
Pre-computed, but might be better. Right? Okay. So, right. And then we probably want something like include hydrogens as the name for that option there. And this keculize thing, what is that to do with benzene or something? What is that?
Right. It's do you want to mark all the bonds as equivalent and aromatic, or do you want to mark some of them as double and some of them as single?
I see.
It matters in pattern matching and stuff on here and the plotting functions.
Okay, so that needs a name, and I don't think is that a standard name in the business for that operation? And what does it mean when you say keculize it?
To turn all aromatic bonds into alternating double and single bonds.
Is that really what that fellow did? I thought his big insight was that it was a superposition of those things.
Actually, no, it was that it was a ring.
Yeah, that's what I
see.
thought.
Just that it was a ring.
Just that it was a ring. He was the one that.
No, okay, fair enough.
Yeah.
Okay, but then the notion that there is this superposition of states is, so I don't understand why it's called keculize. If what it really is to, what is the difference that you're saying that you have either this aromatic thing or you have explicit alternating single and double bonds? Is that right?
Yes.
Right. Yeah. Calculus formulas were alternating single and double bonds, and that's why that name is attached to that form.
Okay, fine. All right. Well, it's a weird enough word. It certainly won't conflict with anything else.
And so,
keculize. I mean, you might say keculize bonds. Might be a reasonable name for the option.
Kekuli bonds.
Well, if it's called keculize.
Well, so there are oftentimes Kekuli structures, or you take the structure and you kekulize it, keculize it.
Yeah, I don't like using his name as a verb, though.
Well, so okay.
We'll find something.
Okay, so let's go with that for right now. But so then, if I'm not mistaken, if you have, so if you've given the molecular coordinates, the stereo piece, I don't understand why does stereo element have a wrapper here? It's the third argument of molecule, if I'm not mistaken.
Right. So, so that any structure that you come up with, if you did not give it coordinates, needs to fit that that stereochemistry relationship.
I get it. But I mean, but why is this stereochemistry, for example, not, given that molecular coordinates is an option, why is the stereochemistry not also an option? Because you never need to give both. I mean, in other words, if you've given the molecular coordinates, the stereochemistry is completely determined.
Yes. So whether they're options or whether they're a wrapper, that's one of the arguments. You would be able to specify incompatible options, and that will be something.
Well, sure. So something has to win, and presumably molecular coordinates will win, but generate a message.
Yes.
Saying these molecular coordinates that you've specified are inconsistent with the stereochemistry. I don't really see that. I mean, to me, it seems that having the bag of atoms first, it's a little bit unclear to me. I mean, the bag of atoms, then the bond structure, and then then after that, you are giving, I don't quite see that why the stereochemistry should be an argument there, why it isn't an option.
Well, there are cases where people will draw a structure and they don't specify the stereochemistry. For example, methyl cyclohexane or 1,3-dimethylcyclohexane.
What does the stereo element mean? So what does the 1 mean there?
So atom number 1 is the stereo center. It's a chiral center.
Okay.
And so if you look along the bond between atom 1 and atom 2, atoms 10, 9, and 20 will be arranged in a counterclockwise manner.
Okay.
You could simply associate this word counterclockwise with this, and the rest would be inferred, but it's not really a single atom property, so we write it like this.
Mm-hmm.
But wait a second, but I mean, isn't that redundant then? Given the 1, do we know from the bond structure here, we immediately can deduce just from the graph theory of it that there will be 4 atoms there. Is that right? 4 other atoms around this 1.
Right, but the order is important.
I see. But
and so if you don't give this,
okay. But so really, it's around 1. There are those things, and by the way, they're counterclockwise.
yes.
Right? Okay, but we could assume counterclockwise, and it could be a third argument. I think it'd be more natural to have the center first, Roger, do we have any precedent for this in meshes and things?
No.
In organic chemistry, the 4 ligands attached to the central atom are assigned, it can be assigned a priority. And that requires examining the full molecular graph to do that. What we're trying to do here is something similar, but without assigning the priorities. The priorities would be implicit by their order. And we could do that, Jason, and not have to say that you're looking specifically from 2 to 1, and then the others are clockwise or counterclockwise.
So give the absolute stereochemistry rather than the local stereochemistry.
No, it would still have to be local, and it would be implicit by the implicit priorities would be 1, 2, 3, 4, or 4, 3, 2, 1, our choice of the ligands. And then we would just apply, you know, the standard RNS rules or for that implicit set of priorities. That does run counter to the true canonical Prelog RNS notation, though, that would be based on the full molecule. So we need to keep it local. We need to find a notation that works. Everybody else has used clockwise and counterclockwise as the local labeling for it, but the way they handle what's clockwise and counterclockwise differs from one implementation to another.
Okay, all right, but so there's a question of, okay, can we, I just want to get some scope for what's going on here, and I am supposed to give some video conference talk in 6 minutes if it's on time, and I'm trying to determine whether it's on time. Is Eric here, Broderick? Okay, can somebody find him, please? Okay, well, I don't know how long I can keep going here, but let's get some scope of what's happening here. So can you scroll down a bit?
Yeah. Okay. So that was stereo element. Also important is 2 molecule, the way of generating molecule from a SMILES string, an INCHI string, a name.
Did we have that before?
Previously, I just had molecule taking a string and evaluating
that. By the way, with these design reviews, it's kind of important to remember what it is we already agreed to and what's new, because otherwise we're going to go back over the stuff we already agreed to. So this is something new, is what you're telling me.
Yes. So I was trying to limit the scope of molecule and the evaluation semantics of it. But if
I don't think 2 molecule is the right thing. I think that's I mean, this is trying to take.
I think it's actually the nearest what we have to existing to entity from entity.
So sometimes you need to specify options, parsing options that aren't necessarily valid on a full form of an evaluated full form. So telling it that what I'm giving you is a name and it's not a SMILES, although I can't even think of where they would overlap. But sometimes if you give it a sequence, you need to tell it what type of sequence you've given it.
Okay, so hold on. So then, okay, that's not
the main reason to have other constructors is when you need to provide control, you know, and there's good reasons for providing that control.
Right, which I don't think is the case here. That is that what we're doing. I
mean, can I just give it a rule? Molecule name goes to benzene, so that I know to parse this as a name.
Possibly, yes. But I mean, what else would you parse it as? I see a SMILES string or something.
Right. And so the reason I wanted this is when you give a SMILES string, sometimes it's invalid and sometimes it's invalid, and I can tell you why. But if I'm going to just roll through and try all of these, which was, if it were automatic, I would just try this, try this, try this, try this, and then if none of them work, spit it back unevaluated. But if I know that you were trying it,
no, but that's
Okay.
just an implementation detail. That's not part of the design.
okay,
I mean, hey, listen, unfortunately, I have to go because I'm supposed to be going to give this talk. So we have to continue this hopefully soon, like tomorrow-ish, before we all forget what was going on here. I mean, this is really cool what I'm seeing here. Let's we need to continue later. Sorry.
okay.
See ya. Bye.
Bye.